So in this lecture, we're going to cover part two of a two-part lecture on the where clause in the SQL language. And so in the first lecture, we covered just a brief introduction to the where clause. One thing I'll reiterate again for this lecture is that the where clause is applied to records within the table source. So you're essentially, SQL is going to go to that table in your from clause and then execute any conditions that you have specified in your where clause. And so what that means is those conditions are applied to that original table. And we'll see why that's important again, kind of at the end of this lecture. And so we covered some simple logic that would appear in a where clause with basic operators such as equals, the and operator, that does not equal symbols and operators, and then the not operator or keyword operator as well. And then we also so we covered how that looks with numeric data. We also covered how that looks with string data in SQL. And so the SQL language uses single quotation marks to denote strings within your query. So, for example, Boston here, right? You use single apostrophes. This where clause is going to evaluate at the record level where city is equal to the value Boston. I did cover in the prior video that SQL, when you supply values, character values, it does not treat them case sensitivity. Now you can enforce that, I think, through some kind of option, but by default, SQL would treat Boston with a capital B the same as Boston with a lowercase b. And that's not true in all programming languages. For example, R is case sensitive in general, so both within the language itself and also for character values, string values within data. And so in this particular video, we're going to go a little bit deeper on the kinds of conditions you can introduce through the where clause. For example, comparison operators. Then we also will introduce compound conditions, which is having more than one piece of logic to evaluate. And then we'll also cover parentheses in SQL and with conditions and why they're important, and it really applies to all languages in general. And then we'll also cover column aliases and why they're not supported in the where clause. And then we'll ultimately go to some examples as well. So jumping into the comparison operators, comparison is maybe a bit of a misnomer because equivalence is ultimately a comparison, but this was ultimately to support some grouping in a way that I think makes sense. So in comparison, going beyond equivalence, we would look at cases of greater than or less than or equal to together with that. So in the first clause, right, we're going to filter in, or SQL is going to filter in records where the state value for the state province ID field is greater than 79. In the second clause, it's going to filter in records that are less than or equal to 79 for the value of the field state province ID is less than or equal to 79. If you haven't seen this before, this is pretty standard for a less than equal sign, or greater than equal sign would ultimately put that equal sign after the greater than or less than sign. And that's pretty standard in programming languages, but in case you haven't seen that before. And then you can also do comparisons with dates. So where a modified date, a value for the field modified date is before or less than January 1st, 2008. It takes this form, and then note that your date is ultimately treated or written within your query like a string. So it has single apostrophes around the date. And this it basically indicates this logic is saying, go to the table source, look at the field, modified date, return only, use records for your larger query where only the modified date is before January 1st, 2008. Then there's the between keyword or operator. So for example, in the first one where we're looking at numeric data, where state province ID between 68 and 79 is ultimately telling SQL, go to the table, look for the field state province ID, only return or use records that have a value between 68 and 79 for that field. and that includes those values. So if those the values that you specify. So if state province ID has a value of 68, that record is going to be included as part of the processing of the larger query. In the second clause, we have where modified date between January 1st, 2008 and December 31st, 2008. So it's basically telling SQL, use the records that have a year of 2008 for the modified date field. And one thing I want to point out, kind of a special note, in the United States, the format of a date is a month / date, or month, the month / the day / the year. So the month comes before the day. I know that is not the case internationally, where the day comes before the month and comes before the year. So if you downloaded a SQL, the default likely will be in this format, where month comes before day, comes before year. Just something important to note, because if you this can ultimately cause confusion if you're looking at like the difference between January 10th in one method, it would read January 10th, 2008, and under a different method, it might, depending on how SQL is interpreting the order of the months and the days, it might ultimately return October 1st, right? The difference between 1/10/2008 and 10/1/2008. So it's important to keep in mind. And then we'll also look at the like keyword or operator. And specifically with the percent symbol as the wildcard. So like is really more for text mining. I don't use it in practice because I tend to answer problems where character values are more explicit and known. But this ultimately allows you to search within character data or character fields for values that have certain strings within the larger value for the field. So, for example, where a city like C percentage symbol will basically return all records where the value for the field city starts with the letter C. And then if we were to expand that, right, to CIN percentage symbol, this is basically returning all the records where the first three characters start with the string CIN. The third one will find CIN anywhere in the string, and that's different from the first, this example above it, in that this is the first three characters, whereas this can be any three characters within the string. And then lastly, if you have the percentage symbol first followed by a string, that will, and no percentage symbol at the end, that ultimately is saying, look at the end of the string, only return those strings that end with town or TOWN. And we'll ultimately jump to SQL to see some of those examples in practice. Actually, I just might do that now because there's enough examples there to kind of talk through. So let me exit out of this. Go through. So this is part of the larger script. So the first parts in here were what was covered in the first lecture, equivalence, non-equivalence, and then we're going into comparisons. So just running down the list of the examples that were presented in the slide. Do note, I'm going to run this before I say what I was going to say. And we're going to see, essentially, I'm going to have an error, right? It's telling me invalid object name, person, not address. And that's because if I look up here, I didn't specify my current database explicitly in the table source in the from clause. And so what I need to do is use the use clause or select it from the drop down. And ultimately tell SQL to set AdventureWorks 2019 as my current database. So if we go and run this again, we'll get records where state province ID is greater than 79. So we'll see the records that are returned ultimately have values greater than 79 for the field state province ID. The alternative or converse logic would be less than or equal to 79. So when we run that and return the first 100 records, we'll see that they're all less than or equal to 79. And so there's a batch of records with the value 79, and then there's various other records, but ultimately they're always going to be less than or equal to 79 for the field state province ID. The next query will be using a date. So this is before January 1st, 2008, and select the top 100 records. And I ultimately told SQL I did supply an order by clause so that you could that would sort the output by the modified date. So you can see, the first one is June 23rd, 2006, and then you'll see ultimately that no date for the modified date field is after or on January 1st, 2008. And then ultimately you see only 9 records satisfied that criteria, even though we told SQL return top 100, the first 100 records. And so because there weren't enough records that met that criteria, SQL is just going to return up to 100 records. And then again on the date, right? The default date formats, I should say, in the United States for T-SQL are month, month / day, / year, right? But you can ultimately use different forms or different notations for those dates. So you ultimately saw over here, right, in the results that were returned, it's year, dash month, dash day. And so that would be this format here. SQL will accept dashes or slashes, forward slashes. So ultimately, how you specify the date is up to you, but be conscious of the order of month and day and how SQL is processing that information. You'll ultimately know, right, if you supply a date that doesn't exist. So just trying to come up with an example here off the top of my head, usually occurs when you pick a day that's greater than 12. So I'm going to pick the date December 15th, right? And so if I supply 12/15 in which is the default format here in SQL, it's going to process just fine because it's month, day, year is the default, at least on the version that I've configured or installed. And so if we go left, right, everything is as intended. Now I expanded, there are more rows here because I did introduce a date that was ultimately after January 1st, 2008. But if you were, unknowingly, let me just supply this date here, right? SQL is going to return an error, or it should. So the conversion of it's essentially converting that data to a date resulted in an out of range value, right? There is no 15th month in the calendar. So just something to note. I'll change these back just in case I modify things later. But there's something to note as you work with dates. Then the between operator, you'll see in the first example, we're selecting records where state province ID is between 68 and 79. We're ordering by state province ID ultimately so that I can show you that there are different values. So 68 is included in the midpoint. There are no values for 69, which we did confirm through in the prior lecture. And then going all the way down, you'll see that if there is a value of 79, it will appear at the end, right? Because it includes the midpoints. And then you'll see anything in between. Let's just try to go in there. We already saw 70, but so 77, right, is between 68 and 79. So the records are returned. And there are ultimately 4,182 records that meet that criteria in the table source. Then going on to the next example, which uses dates. So we're going to return the records where the modified date is between January 1st, 2008 and December 31st, 2008. That includes endpoints again. So if we have values of January 1st, 2008, which it doesn't look like we do, or we do have values of December 31st, 2008, those are ultimately included or output by the endpoints that are supplied in between conditional logic are ultimately included in that output or that evaluation of whether a record is successfully meets that criteria. And I did again use an order by here just to show that the range of values that are returned through the between operator. And then we'll look at some uses of the like operator, which again I don't use it very often, but just so that you can see SQL supports it. We're going to return records, all records where the city starts with the letter C. And the percentage sign basically means ignore anything that comes after it. So you'll see Calgary, Cambridge, right? All these cities start with the letter C. And so we could answer a question, right? How many records in this table have a value for the field city that starts with C? Well, that's 1,847 records. And then we'll look at if the city starts with the letter CIN, which the list gets much smaller. I believe it's just Cincinnati. So there are 4 records there. And then looking at the next query, we're going to return anything where the string CIN is found. And so this differs, right? Because this CIN can appear anywhere in the value for city, whereas in the first, because we didn't have a percentage sign at the front, we were basically saying first 3 characters must start with C, I-N, C-I-N. Now, if we run that, right, we get one more record supplied, and that's Racine. And you'll see the CIN is here in the value for the field city, so it's included in the processing or the output. And then lastly, right, this is just at the end of the string. We'll select town, select city, values for the field city where the last 4 letters in the string are town, T-O-W-N, and you'll see that only 2 records are returned. We want to see if town generally appears in the string. Anywhere within the string, we would add a percentage symbol to the front. And we'll see there are quite a few more that meet that criteria. There's Townsville, Baytown, which I think was originally returned. It might ultimately be these 2 values are the only ones that are returned, but just to show you how those differ. Sorry, 1, 2, 4. Okay. And then we'll kick back over to the SQL PowerPoint to discuss the compound conditions. And so try to focus on this one a little bit more high level because you don't, right? The thing about logic is that you can introduce as many clauses as you want, but at the end of the day, they're all kind of based on these single conditions. And so a compound condition has 1 or more, or has 2 or more conditions. So for example, in the first clause, where clause, we have return records where both the value of city is Berlin and the postal code is 10791. Notice that I enclosed that value in single quotes to reflect the fact that that field is actually comprised of character data as well, because it's just not United States addresses, which tend to have a numeric zip code. It's also other international, Canada, France, the UK, and they have different values within there that have characters within them. And then on the second clause, we're saying basically return records where the first name is Michael, and then the field value for the field email promotion is not 0. And then in the third clause, we are saying return records where state province ID is greater than or equal to 68 and is less than or equal to 79. And so what does this mean? This is the same exact logic that we used with the between operator in the prior examples. So you're going to return records within a range. They have a range of 68 to 79 for the field state province ID. And so these are conditions with the and clause, right? You're telling SQL make sure that the clauses that I joined together with the and are both satisfied in order for the overall condition to be satisfied and the record to be returned. And then with or, that's the opposite or the converse, right? Only one of the conditions supplied between the or operator need to be satisfied in order for the record to be returned. So in the first example, where state province ID equals 78 or state province ID equals 79 is really telling SQL return a record if it has a value of 78 or 79 for this field. This is the same that we saw in our equivalence examples in the first lecture with the in keyword, right? So where state province ID in 78, 79 accomplishes the same thing. And then the second example, where state province ID is less than 68 or state province ID is greater than 79. And this could ultimately be phrased in a different way through the not keyword. It's essentially everything outside the range of 68 or 79. So basically the converse of this logic here. Parentheses are your friend when you start talking about compound conditions, because SQL has a built-in order, it's called operator precedence. So it will process, when you're using more than one operator, it will process the conditions in according to the order that it's laid out. So in the examples, and we'll talk through them, not is processed before and, or and is processed before or. And so if you think, right, that the way that you've listed your logic in the where clause is the order SQL is going to process them, that's not the case. So with parentheses, you're essentially telling SQL, this is the order that I want you to process them, right? This group in the parentheses process first, and then handle things outside the parentheses. And so these examples, the first example here and the second example, don't look all that different. All that's different is the parentheses, but the logic is ultimately different. So in the first example, and it's going to be a lot easier to see the examples in practice, which we'll kick over here in a second. The first one is saying basically don't return the record if the value is greater than or equal to 68. So don't return it then. So the value has to be less than 67, and the value has to be less than or equal to 79, which doesn't make a lot of sense computing-wise, right, or logically, because you're only returning records less than or equal to 79. So this logic here essentially becomes a moot or redundant portion. That's different, however, than what is in the second clause, which tells SQL supply everything outside the range of 68 to 79. So it's going to go in, select records between 68 and 79, and then it's going to exclude those from the final processing. So those two things are different. And then and takes precedence before or. So in this first clause, right, we have city equals Boston or city equals Cincinnati, and modified date is less than January 1st, 2012. So SQL will process and before, so it's going to evaluate this condition right here. It's going to evaluate the city equals Cincinnati and the modified date less than January 1st, 2012. And if that's true, then it will return the record, or is just the value of city equal to Boston. And it has nothing, it doesn't consider modified date at all. And that is ultimately different from the clause below it, where we put parentheses around. You can have a city name of Boston or Cincinnati, and then leaving that aside, the modified date must be less than January 1st, 2012. So that modified date criteria here is actually applied to values of city outside of Cincinnati, whereas in this first example, it was only being applied to records with the value of Cincinnati for the field city. And so let's kick over to SQL and go through those examples. So looking at the compound conditions here, the first example, city equals Berlin, and the postal code equals 10791. Just running that, right, we see it returns the values for the city Berlin, right, and a postal code of 10791. So both an and means that both of these things have to be true. Let's cut off the and clause, or the and compound, and just look at values for city of Berlin, right? So we have all these different postal codes here. And so introducing compound logic requires, with the and operator, requires both conditions to be satisfied. I didn't put single quotations in this example because SQL is able to evaluate the postal code as a numeric, or essentially it would have converted it to a character data type in order to run it against all the values. So there is no difference, right, if I force that value to be a string. SQL kind of handles the conversion in the background. I do use a different table for this particular example just to show you some different data. So in this table, person.person, we have various first name, middle name, last name, suffixes, and then this field email promotion, which is probably related to what email promotion, if any, they received. And so in this logic, we're returning only records with the first name of Michael, and then also excluding records that have that condition satisfied, but also display a value of 0 for email promotion. So you won't see any records, Michael and 0 within the output. And we can kind of show that those records, well, they may or may not exist. I don't know until I run it. But you ultimately see this record would have been excluded by the compound logic. And then going over to this example, I'm not going to focus on it too much because it's the same exact one as between, right? We saw that there were 4,182 records between those values, and that is essentially identical syntax I can run, or identical logic, I should say. And I'll run that again just to prove it out. So 4,182 records. Moving on to the OR compound logic. So one of these things is satisfied. I'm going to execute this condition or this query that has the condition that state province ID must be 68 or 79. And you'll notice, I'm not sure that I did it here, right? There are 2,636 records. If we were to just order by state province ID, we'll see that no records have a value of 78 for state province ID, right? Because we start with 79. And so if that was satisfied, they would have been displayed first. Actually, just remove that. And moving on. So this is basically saying return the records where state province ID is either less than 68 or it's greater than 79. So we're excluding records between 68 and 79, including the endpoints. And so this will essentially be all other records in the table outside of those 4,182. And we'll see there are 15,432 records. And if we go through here, right, we're going to see it's either less than 68. So that's true for all of these, and then or it's greater than 79. So that's the case for this particular record and why it was included through this second compound condition and the or operator. And then to go through these examples in depth where operator precedence is at play and you're ultimately returning parentheses make a difference, right? They'll change what's returned or whether a condition is satisfied. So if I run these two queries together in tandem, and then I also did just returned distinct values for state province ID just to illustrate the fact that they're not the same. And so that's just returning unique values, and then it's ordering by those, right? If we start to go down the list, we can see that the same records would have been returned with these values. Keep on going. The difference is going to come in at 68 probably, right? And we see, keep on going. And these essentially stopped at, this one stopped at the value 67. So it excluded any records that were, that met this criteria, right? Because it didn't meet the first criteria, and we're saying that it must meet both. I know I kind of messed up in the lecture and said that this one was redundant when in fact it's really this one that's redundant because the values of that are returned can't exceed 67 according to the valuation of this clause. When we introduce parentheses, however, we're telling SQL to not include it if it's greater than or equal to 68 or less than or equal to 79. So in that particular instance, you can see that ranges between 68 and 79 are ultimately excluded from the output. And then working with and or, we'll do this one at the record level. That one is ultimately just to demonstrate how the logic is different. So the first example, we're saying the city equals Boston or the city equals Cincinnati and modified date is less than Jan 1, 2012. And so we get two records that satisfy that criteria the way that it's written. You'll see the first one has a value of Boston for city, and the value for modified date is less than January 1st, 2012, or I'm sorry, greater than January 1st, 2012. So it's February 2nd, 2012. And essentially this logic or this condition did not apply to the first record because this portion of the code was evaluated first only for values where city equals Cincinnati. And so Boston would be returned regardless of the value for modified date. And compare that to the second example where we were more explicit with our parentheses and told SQL, look at city values of city first independently from modified date and return Boston or city, and then look at all records independently of city where modified date is less than January 1st, 2012. And you can see that record for the city Boston with a date after January 1st, 2012 was excluded from the bottom. And then last, I know this video is getting long, but a lot of stuff with logic and where clauses and how they can fool you and how they can get complicated, frankly, very quickly. And that kind of goes to a point that I introduced in the other lecture, is that I'm not sure that I actually explicitly put this in the PowerPoint, but typically your logic gets pretty complicated in practice in a where clause because you're filtering and scrubbing data, and you have to introduce a lot of logic in order to do that because there's rarely just one issue with the data or one thing that you want to include or exclude. So again, that reiterates the point: when you have compound logic, more than one condition, make sure you use parentheses, especially when there are intersections among them. And then jumping to where and column aliases, let's see if I can do this quickly. The point here is because the where clause is the logic in the where clause is applied to the table source listed in the from clause. This means that you cannot use column aliases that appear in your select list. They don't exist in the original table that's part of the from clause. So that an example here, we're providing the city name alias for the field city in our select list. We try to introduce that same alias in our where clause, we're going to get a syntax error, and we'll see that in a second. But what this does mean is that you don't need to just use an element in your select list to introduce or to apply logic. So you'll see in this particular example, we're selecting the top 10 city, but we're ultimately applying the logic on a field that's not going to be shown in the output. So we're only showing the city name where the state province ID is equal to 79. So to show this in practice, just show what this looks like at first, right? So we selecting the first 10 records for city, for the field city, and supplying an alias city name underscore name here. And so that does not exist, and this field name as written does not exist in the table. And so when we go to introduce where clause on a field that doesn't exist in the table, we're told by SQL that it doesn't exist. So it's an invalid column name, right? Because that column name, city underscore name, does not exist in that original table. Again, though, we can apply, and I'm going to run these two. I'm not sure that I can do that without. One thing I'll show here in SQL now is that you can block comments, right, with this button, or it looks like it's Control K or Control C. And so I'll run these two in parallel just to show the differences, right? And so you can see we in both instances we have 10 records for the field city name, but this query ultimately will include city names where the state province ID is equal to 79, and this one, they will both include it. But this one, the second one, will actually exclude any records that are not 79. So we might have, right, we didn't return all the state province ID here, but we will, just to make the point a little more. Sorry, one second. I should have done that after the comma there. So state province. we'll do that again for the bottom so that we see the field on which we're applying some logic in the background, right? You'll see Seattle's in there, but there are other state province IDs other than 79 and from the first query. In the second query, you'll see that the output or the city names, right, are really restricted based on the value of state province ID. So the point there is that you can use fields that don't appear in your select list as a basis for applying logic. And so that pretty much concludes the video. I know we covered a lot, but really talking about the more complicated portions of logic in SQL. And you know, as always, reach out to me with any questions that you have.